Hello and welcome to another episode of Risky Business. So for this one, I got the scene switched back to, how it was before, so you can see this a little more up close since we're working on this more than we're messing with the hardware. So we're gonna, focus on this stuff here. So we left off, I was kind of, just putting this one in. I think I finished it up after I've ended the recording, actually, but yeah, I just put that one in there. It's this line right here, and here you can now you can actually see the code that we're writing here. So the fn variable just is like how many fragments to use to render this stuff. So like if you do, like I showed in the last one, if you do like a circle and you say 5 fragments, you get a pentagon, that gets rendered, because that's the closest approximation you can do with 5 segments, right? So we've set that to 100 for now, so that we can get a fairly nice render without hampering our performance too much. It seems to be performing fine, but if performance becomes an issue, we can just lower that. And then we have our variables. I'm just calling the expansion board exp. So we gave it a width, a depth, a height. These are in millimeters. And then we did the standoffs. So the standoffs, we just extruded, a rectangle down to make a box that covers the area that the standoffs sit in, and they're like 18 millimeters high. So and then we're working on the points for which is the center of each circle, where the standoffs are, that where we can actually screw in screws to hold the board down. And then here's the code that's actually doing this stuff that you see on the right hand side. So we did a square, which is the width of the board and the depth of the board centered, and then we extruded by the height of the board. So you could do the same thing if you use the cube function instead of a square plus an extrude, but I like to build up from, start with like a 2D sketch, and then that's kind of a more typical way you do things in CAD programs. But you could just as easily start with a like a 3D object instead. And this, you can do that in OpenSCAD, but I chose to just start with a square, which is, it's a rectangle, but they call the function square. Kind of a poor naming choice, but whatever. And then and then we just translate it up by the height of the standoffs, and so that gives us our board, which is we're looking at it upside down right now because we're looking at the standoff stuff, but that's the if I go in here and put a exclamation mark here, see, that's the board itself, right? And then this thing here, we have difference of this thing and all this stuff, right? So that just says, cut out. So like take the first thing in the list, right? Like it's a list of stuff, and so you've got this first one, that's going to be your solid object, right? And then it subtracts, it cuts out all the stuff that comes after it. And the for loop is kind of like a, like a macro, it's like a static for each in like a programming language. It just repeats the stuff inside of it. It's like a, it's just like pasting this a bunch, basically. Yeah, that's essentially what this is doing, right? So where it changes p each time to be, you know, so here are all of our points, and then I'm just saying, you know, make a circle with, you know, 5.5 millimeter diameter, linear extrude it by 2, and then translate it to, you know, the first coordinate, which is the x coordinate, and then the second coordinate, which is the y coordinate, and then for the z, we just go -1, and then so that translates it into place, and because it's in the difference here, that it makes these circles, and then the difference cuts, you know, cuts them out. So if I you know, if I do that, you can see these are all the actual circles we've put into place, right? So these are the actual cylinders, I guess you'd say, because they're extruded. But that's what we're putting in, and then we're just subtracting that from this block here, right? So when you subtract those from that, you get that, right? That's what we're doing. So now you can kind of see the actual code that we're writing here. I think we can get rid of some of the curly braces too, actually. I think if there's, it's like in C where braces are optional if there's just one thing. So I just want to try this and see if we can do that here. I feel like we should be able to get rid of all of those like that. Yeah, it looks like that worked as far as I can tell. So let's leave it like that, and then you know, I'll format this when I'm done writing it. But yeah, it looks like we left off with three more standoffs to figure out where they go. So let me see here. I believe there's going to be one like around here, and see, we've got this one, we've got this one. Okay, there's going to be another one down here. It looks like it's the same distance as the other one, just on the other side. And then there's like another one here and another one here. So I think we only have to measure 2 of them actually. So let's put in the one we know, because it's just the mirror of the one we just did. So that's going to be okay. Let's see. So same in the x direction, right? I believe that should be the case. Let's see here, 87.5, and then exp temp divided by 2 plus 4, but we need to put it on the other side. So that means it's going to be just flip these 2 signs, right? Yeah. So I think that should be right. Looks right to me. Okay. Now we just need the last 2. So those ones we actually have to measure. Okay. So I think there's not going to be an easy way to do this other than just actually measuring. I think this one I'm looking at is 2 centimeters away from the edge of the board. 4 millimeters on one side and 2 centimeters on the other. Maybe a little over. Let me try the calipers and see if I can get a slightly better measurement. Yeah, it's got to be either like 20 or 21. I think I want to go with 21. According to the calipers, it's closer to 21 than it is to 20. But it's somewhere in that range. So we're going to call it 21. Okay, now that is the one. Now wait a minute. Oh, okay, yeah, that's right. Yeah, that should be the one on the bottom right. So that is going to be exp width divided by 2 minus 21, I think. Something like this. Oh, wrong. Wrong, like this. Yeah. So we're gonna go with that, and then we just need one more. And then we'll start modeling some of this stuff on the, the other side of the board. Okay. So this one's like, sort of halfway. I'm gonna do 2 measurements here. First measurement I'm gonna do 59.3, so it's probably around 60. Try to get it close to 60 and see how that looks. Yeah, I don't know, it's around 60 away from 60 millimeters away from the one just past the 3 sets that we did, the 3 bars, metal bars, right? It's like this one right here, it's like 60 millimeters this way from it. Now I'm going to measure from the end of the board, and then we're going to try to, you know, confirm those two measurements, see that they match more or less. Okay, from the end of the board, we must be looking at a little shy of 15 centimeters, 14 points. I'd say 8 or 9, maybe 7. I think 14.8 probably. Maybe 9 though. Maybe 9. So somewhere in that range. Now let's okay, which one was this? Not that one. This one right here? Oh, it's got to be this one right here, right? This one? Just gonna guess until we find it. Yeah, it's this one. Okay. So this one right here. So that one was 87.5 away. So if we said 87.5 plus what was it, like 60? 147.5. Yeah, I was saying it was like somewhere between 147 and 149, right? So that seems to match up pretty good. Let's call it 148. So yeah, we're just going to take this line And oh, we could call it 147.5. I guess we did 0.5 for these ones, right? Let's just go with 147. Well, I was leaning towards 148, maybe even 149 when I was measuring with the ruler, so let's round it up to 148. So I'm just going to say 148 here. Okay, that looks good. So we are done with the standoffs now. So those are our standoffs there. So let's reorient ourselves here. Now, so yeah, this is the top of our board here. And we're going to be putting some stuff in place. So we want to do, like, you know, USB ports. The SATA connector kind of sticks out a bit. And I mean, eventually we're going to do the cards as well. We're going to put the cards in and roughly model where they sit as well. But for now, I just want to get some of this stuff on the outside that we want to have access to. So, well, I mean, I guess we don't really need access to a lot of it, because that stuff doesn't do anything anyway, right? For now, we would need to, you know, I mean, the SATA connector does, but we don't have an extra hard drive for our RISC-V PC right now. Maybe we'll get one sometime, but I don't really see the need for that right now. But I believe that's the only thing, because that functions as part of the PCI, you know, Express stuff, basically, which the FPGA is programmed to do. But that's the only thing it's programmed to do. So like the, you know, the micro SD or the micro or mini USB, whatever those were, and the, you know, USB and HDMI, none of those, the, you know, the FPGA isn't actually programmed to use those. So really, you know, the only thing we're going to need to have access to on this board, you know, like for now, is just you know, the peripherals, the other cards that we're going to be, you know, slotting into this, and the power stuff, I think. So let's model the power, because we're going to need that. And then let's maybe extrude it up to kind of cover the height of where things sit. But other than that, you know, we're just going to make the case a little bit larger anyway. So it doesn't really need to provide access to all that stuff. When we do a better case in the future, of course, we'll want it to actually, you know, provide access to all the stuff the FPGA or the expansion board provides, even if the FPGA isn't yet programmed to support those things. You know, even if we can't drive this stuff, the hardware is there, and so it would be nice if the case actually exposed those parts, you know. But for a quick thing that we're just whipping together to demo, I don't think we really need to bother. So let's just do like a, you know, a flat extrusion up from this thing, you know. And yeah, I guess I'll go up by the height of this tab. That's the highest thing, is this tab for the HDMI parts for like screwing in, you know, if we were to actually do something like that. It has like a little metal tab sticking up there, and yeah, let's see how high that is roughly. And then we'll just extrude up that much and say, you know, the case, you know, we want the bottom of the case to, you know, well, maybe we don't want the bottom of the case itself to even go up that high. Probably just up to like the board, you know. But yeah. But I'll just mark that region off with an extrusion. Hmm, 26.15, thereabouts. If we measure to the bottom of the case, get like 28.7, so 26.7, 26.5, I'd guess then. So let's just extrude up by 26.5. So we're going to start with the same square. But for the linear extrude, we're not going to go up by the board height. We're going to go up by the, what did I say, 26.5 or something? 26.5. Going to go up by that amount, and then we're going to translate it up by the height of the standoffs plus the height of the board itself. Yeah. So that transparent region there just represents, you know, place where components are on top of the board. You know, there's stuff sticking up here is kind of what this transparent extrusion is saying. That's kind of why I put that there, just to say, you know, in this region thereabouts, there's kind of some stuff sticking up. So, you know, you don't want to have something sitting tight, you know, like, not that we're going to have something at that level anyway, but, you know, just as a reminder, like, there's stuff in this region, right, that we're not accurately modeling. We're just sticking a, you know, a big transparent cube over it to say, yeah, that's where the details are. So, with that, the one part I do want to actually model, more or less, is the power region. So to provide access to that, I think I just want to cut a blackout, you know, from the transparent region. Just cut a little cube out to say that's kind of where the power stuff is, you know. You're going to want to have the case kind of open up in that region so that you can access that, basically. I'm not going to try to make a nice fit. I think I want to have a rather, you know, just like a hole in the case where you can reach your finger in and access this stuff, basically. You know, something nice and simple. So what is the size that we need for that? Let me take my calipers here. Mm, 13.5. Yeah, 13.5 would be kind of how far we want to cut in. Let me write this down. So now, how far is it in the x direction? Hmm, 32.85, let's call it 33. You don't need to be super accurate with these measurements. Okay, and then the height, and then we're also going to need to know how far we need to translate it by. But, okay, for the height, we're going to go for like the height of the button, basically. Or, well, no, I don't want to actually model height, because I want to just cut out the entire region, like all the way up. Like it'll just, the case will just like go in that region, like it'll go around so that that part of the board is exposed, basically. So for the height, let's just say the full height of the thing, which was 26.5, is how much we did a linear extrude by. So let's put in 26.5. So basically we're going to do a difference. Let's do a cube, center equals true. Or no, let's not do center equals true, because that centers it. I think I want to measure from the side of the cube, basically. But yeah, we need to translate this to be in the right place, so... So first of all, translating it in the y direction should be easy. And translating it in the height direction should be easy. So let's do those first. Translate. Okay, so height is just going to be the same. Standoffs plus exp height. And then for the y direction, exp depth. So if I just put this here, okay, did that cut anything out? Doesn't look like it. Show me only that. Okay, no, that's in the wrong place. I was expecting that to be... Or wait, no, that's in the right place, possibly. Maybe we should just do center equals true. Because we did that for the square. Then I believe it would just be yeah, divide that by 2. Still not exactly where I wanted it. Okay, let me think about this. So, first of all, if we just say 0, 0, right? Where does that put us? Right there, right? And then we want to move up by the depth, right? Wait a minute. Is that what we actually wanted though? I don't think so. We wanted that higher up. I think the center equals true is just confusing me. I don't want that. Okay, so if we look at where we are now, okay, so this is the y-axis that we've moved on. Right. Okay, yeah, that's right. That's what I was expecting. But that's not high enough? Or maybe it is. Yeah, actually, I think it is. I just need to make that a little bit higher so that it cuts through. Yeah. Okay, so that is doing what I want. Now let's figure out the y-axis. So, how far do we want to go on the y-axis? Wouldn't it just be the depth of the board? No. Depth minus the 13.5? No. So we are moving on the right axis. But too far. Okay, yeah, it's divided by 2 because the square was centered. The rectangle is centered. And then I think we also need to do that minus 13.5. Yeah, that's exactly right. So the render is a little messy, but I believe that is correct. Okay, now it's just figuring out how far it needs to go on the x-axis, basically. Oh, and do we still have a side here? We need to punch that that side out. So let's extend it in that direction a little bit. Yeah. So now we just need to get it in the right place. So how much do we need to move it over by to get it where we want it to go? So it's going to be a little bit of a messy measurement because we're measuring from like this point over here, or like, you know, down. It's like from in here basically where the origin of this thing is. So but yeah, we're measuring basically from here. I'd like to say, like, you know, measuring from here goes so many this way. That would be kind of the nice way to phrase it. So first of all, if we want to get it right on the end, that's going to be width divided by 2 minus the 33. Yeah. And this wall isn't getting punched out, but that's not actually where we want it anyway, so I think that's fine. So now we just need to slide it over by however much it needs to be slid over by. So let's figure that out. Hmm, 25 something. I'll check it with a ruler as well. I think it's 25 something or other. Yeah, I'd say 25 looks good. 25 millimeters. Okay, so 33 minus 25 is 8. So instead of going minus 33, let's just go minus 8. Oh, wrong direction. Okay, 33 plus 25. 58. Yeah, that looks right. So what we have here, this is not what the case is going to look like. This is just the board, right? But that's informing us where we want to have a dip in the case, so that we have that region exposed. Basically, when we go to do the case itself, we're going to want you know, that cutout region to be exposed, because there's, you know, power stuff there that we need access to. And I think that's the only thing we really specifically care about for the expansion board. So next thing to do is to do an accurate, you know, or, you know, another rough model of where the HiFive Unleashed, you know, is actually going to sit here, which is going to be like over here next to the power stuff. And yeah, it's just going to be another rough model extending from what we've done here. And then we'll do the USB card and the graphics card, you know, and rough models of those, and slot those in as well. And then once we've done all that, we'll start designing the case around what we have here. So I'm going to, you know, like put all this stuff that we've just done into a module. So I'm going to call this EXB for expansion board. Okay, now let's see if we can get some of this code a little bit less heavy on the horizontal dimension, because you know, I don't want to have my code editor taking up a bunch of horizontal space. So something like this looks pretty good, right? So that is my code for the expansion board. Syntax error. How do we define a module? Something like this, maybe? Yeah, so now if I say EXB, yeah, then we get an expansion board when we call EXB, basically. So the next thing we're going to do is we're just going to forget about the expansion board for now and start modeling from scratch a HiFive Unleashed. And then once we're done with that, we're going to make a module of it, and then we're just going to translate it into place relative to the expansion board, and then we turn them both on. You know, we just call both modules, and one of them is translated over, you know. Because like if we call EXB here, right, what we can do is we can say, like, you know, translate it, you know, up 100, back, or let's do forward, like, I don't know, 50, up 42, something like that, right? Right, and now you see a translated version of the module. So that's an easy way to, you know, take a component and you know, design a component and then place it wherever you want it to go. So that's what we're going to do with these cards, basically, is we're going to design them separately, and then we're going to make modules out of them and place them using translations. So, you know, the EXB will just keep it at its default position, right? But for now, we don't want to worry about that. So now we've got a blank slate, and let's start start modeling a HiFive Unleashed board. So here's the board. Let's take a look at the dimensions here. And I wouldn't be surprised if they have this information on their website on like Microsemi. I think HiFive is better at that kind of thing. Looks like 120 millimeter by 90 millimeter, and I'm guessing 2 millimeter board thickness. .6. Maybe it's a little less than 2. I'm measuring more like 1.6. For this board. Let's just do a quick look. It probably isn't going to tell us the how thick the board itself is, though, if they do have specs. So let's take a look at the schematics. And the getting started guide. So nah, schematics not helping us. Oh, this is the expansion board. Okay, we were correct about the 120 and 90. And yeah, it doesn't look like it gives us the actual, you know, thickness of the board. But I measured it to be around 1.6, a little bit less thick than the expansion board. Which, I'd agree with that, just eyeballing it. It is a little thinner. So yeah, we're gonna go with 120 by 90 by 1.6. So let's add some new variables up here. Oops. Okay, so we're gonna say HU for HiFive Unleashed width equals 120. HU depth equals 90. HU height equals 1.6. And then we're going to go ahead and make a board here. So we're going to do square center it. That doesn't seem right. Oh, right. Depth, not height. Yeah, there we go. Okay, and then we're going to your extrude. Okay, so there is our board. Now again, I don't really care about modeling stuff in detail, just the important bits. So the important bits for us are going to be the FMC connector, the two remaining standoffs, the power region, the micro SD card, and yeah, I guess, I mean, Ethernet and you know, the micro USB too, because those actually work, but those actually are, you know, they actually have the support for them. But I don't think we're going to be using them in the demo, right? Because like the micro USB is just used to like talk to the board over the UART, and you know, Ethernet is just, you know, if we wanted networking, which I don't think we're going to try to do for the demo at Handmade Seattle. I'm not thinking of doing anything networked. I don't know if it would even, I mean, I guess I could ask Abner if Ethernet would be an option, but I think I want to not attempt that this year. Maybe in the future at another con, but not this one. So I think we're not going to bother providing access to those or the GPIO or any of that stuff. I think we're just going to provide access to the power, the reset button, the micro USB, and then, like I say, we'll model the standoffs and the FMC connector. Although, how am I going to want to do this? I think, yeah, I think I'm going to do extruding out by the height of the standoffs, but then I'm going to stop it before it reaches the FMC connector, and then I'm going to do a more detailed model of the connector region. Something sort of like that is kind of what we're looking at here. And then yeah, something like that. So first thing I'm going to do is do an extrusion to cover the region the standoffs cover. And like I say, I believe those are 15 millimeter standoffs. Is that what I said? I suppose we could take the SSD, the standoff that I used from the SSD off at this point, but I think there should be another extra standoff somewhere, right? Yeah, here we go. So I have the other extra standoff here that we removed from the HiFive Unleashed. Right here. Let's measure that again to refresh ourselves on how big that is. Yeah, like 15 millimeter. It was like 14.9 something there. So I'm pretty sure that's a 15 millimeter standoff. So with a 15 millimeter standoff, so we're going to say standoffs equal 15 millimeter. And then, so we're going to do another square, like the first one. So I'm going to need to raise this by the height of the standoffs. Or whoops, that's the wrong, should be HiFive Unleashed. Okay, and then this one, we want to linear extrude up by the height of the standoffs. Looks good. But then I want this to be smaller. I don't want it to actually cover the entire bottom of the board, because two of the standoffs are removed and that region is going to overlap with the expansion board. So that region, I actually want to do, you know, something a little different there. I actually want to model the FMC connector. So the depth, basically, we're going to subtract, you know, some amount. Let's just say 42 for now. Oh, but because it's centered, that's taking off from both sides. So we're going to want to move it. It'll have to be moved relative to how much we take off, basically. like if I take off 42, that's taking off 42 by both sides, so I'd have to translate it down by 21, I think. Yeah. So it doesn't really matter how big I make this. It's just a little region where the standoffs are, basically. You know, that's just this part right here and this part right here. The rest of it doesn't matter. Let's just make it a little bit smaller. I don't think we need to measure anything here. So, let's do like 4 and 8. Oh, that's the that's the wrong direction. Well, okay, let's just figure out how big the FMC connector is and go by that. So let's measure that next. Around 15, but I want to leave a little wiggle room, of course. You know? So I'd call it 15, but millimeters, I mean, but I'm gonna add a little bit of wiggle room. So let's call it like, I don't know, 17 millimeters. Or 18 millimeters. If we do 18, it would be 9. So yeah, let's do that. 9, 18. Okay, so that gives us room to put our FMC connector. Right. So we're gonna have a standoff here, an FMC connector over here in this region. And then on the top, we'll put, we'll do a extruded region that's transparent, like we did for the region on the other model. But then we'll mark off, a region that we need to expose for the power, like we did with the other one. Okay, so let's start on that FMC connector. So let's look at it from this angle. So we're going to put an FMC connector right in this region here. So it's basically 1 millimeter in from the board. And I would say like 6 millimeters in the other direction. So like 6 and so it's like 6 millimeters in this way, and it's like 1 millimeter up this way. So you hit the bottom, corner of it. So let me just note that down. Okay. Now, how long is it? So I would say it's like 56 millimeters. And how high is it? And I guess how long is it here? Let me note this down again. 56. And it actually has a little tab that sticks out there, so probably by 1 extra millimeter. So actually, I'm not going to model the little tab, but it's just like a little 1 millimeter cube that like sticks out on one end of the connector. But to account for that, we need to lengthen it. So let's actually call it 57 all the way across. Rather than, making the little notch, we'll just extend that region out a teeny bit. And then yeah, I'd call it like I'd call it 15. Let's call it 15 as the depth of it. And then the height of it. That's going to be let's use the calipers to get that measurement. I'm going to measure from the other side of the board. That's a hard measurement to get. But I think I want to call it 8 millimeter depth, which is a little generous. It was like 7 something. And I'm trying to measure because there's like a little bit that sticks out, you know, farther than the rest of it. I was trying to get that, but it's, you know, difficult. But I was measuring 7 point something, so I'm just going to call it 8 millimeters. Which is maybe a little bit generous, I don't know. So let's just do a cube. I guess doing cubes is kind of nicer than doing a square plus a linear extrusion. Okay, and then for translating it, now let's start it at 0, 0, and then try to get the height of it right. Okay, so it's going to be raised up by HU standoffs minus 8 for the height. I think that is correct. We'll see in a little bit. Let's translate it down. So HU depth divided by 2, right? Minus 15. Okay, now let's take a look at that. Yeah, that's looking pretty good for the connector. But then we need to translate it along the X as well. So that's going to be Let's see, is that +6 or -6? Must be -6. Or wait. So if I don't translate it, it's going from the origin. First of all, I want to get it up against the edge of the board, and then I want to measure it, you know, back from that. So if I want to get it up to the edge of the board, I want to do HU width divided by 2 minus 57, right? Yeah. And then -6 from there. So 57, well, it'll be 51. I can do that in my head. That's the wrong direction? I thought that's what I just did. Apparently I can't do that in my head. Wasn't it 57 minus 6 that was working for us? Well, whatever. 57 plus 6. 63. So yeah, I believe that's the correct location of the FMC connector. Looks pretty good to me. Seems right. Let's maybe make the standoff regions be transparent also. Just to make that clearer that, you know, that's just a placeholder for kind of, you know, where stuff is. It's not actually a solid region. And then I want to do the same thing. Same thing here, I think. So for a moment, let me comment this stuff out and just check the other model. Yeah, I think I like that. It's harder to see the standoff regions though, but we don't really need to see them well. We can always just change it when we want to see it, and you know, it's in the code, so. Yeah, so this is our rough model of the expansion board. It's obviously a pretty simple approximation, but it'll do. And then this is our current approximation of the HiFive Unleashed. So I'll probably go back into the expansion board model and make a nicer, model for the FMC connector, so that we can line those up, when we slot the expansion board into the HiFive Unleashed into the expansion board. But we'll do that later. So next thing I want to do is put in the regions for the standoffs for like the standoff points. So I'm going to do that the same way as I did the other one. So basically I'm just going to say standoff points equals and there's just going to be 2 points. So we should probably rename these to be more specific. Let's take a moment. Just make sure we didn't break anything. Nope, looks good as far as I can tell. Well, let me just okay, yeah, that looks good. Now for standoff points, basically we're going to do the same type of thing. So we're going to do a difference again. Okay, and that did indeed cut as I expected it to. As for the inner diameter of these things, I'm guessing it's the same. No, these are smaller. This is like 5 millimeters side to side. So if we were to inscribe a circle inside of it, it would be smaller than 5. So I don't think HiFive provided us a part number though, did they? For the standoffs they used. Oh, there are design files. What are in the design files? Oh, it's a zip file. I don't think I have unzip. Oh, I do. Never mind. Just hold on a second here. Okay. I don't know what a SCH doc is or a PCB doc or what these files are, what they use to design it. Let me just take a moment here to look at this. Like, yeah, they're not text files. So yeah, I don't know what software they use to design this, but they're not like something we can just open up and look at as far as I can tell. So there might be information in there, but not easily accessible without figuring out the software they used. Which I'm not going to do right now. Might do that another day. Let's check the schematics again, but I don't think the schematics had what I was hoping to find. Like a, you know, mechanicals section. Nah, not seeing it. So unless I'm missing something, I don't know if we have a documentation on the exact specs of the standoffs they used. Let's just say the circle is 5 rather than 5.5. I feel like that should be fair. Okay. Now we need to figure out where these things go. So we want one over here and one over here, basically. Just eyeballing it, I think it's going to be 4 by 4. Yeah, I'm pretty sure they're 4 by 4. So that should be pretty easy to do. So we're really looking at it from this angle. Okay, so if I want 4, so I think it would be half the width minus 4, half the depth minus 4. Maybe not. Oh yeah, wrong way. Ah yeah, because of I'm angled upside down. Since I'm looking at the bottom of the board. So that means this should be negative, this should be plus, right? Yeah. There we go. And the other one should just be Yeah. Okay. Looks good to me. So that's our model of the bottom of the board. Now we need to do the top of the board. Okay. So first thing I'm gonna do is figure out the height here of the cute little heatsink and fan. So I'm just gonna eyeball it. Let's call it 25. I think it's a little less than that, but it doesn't need to be super accurate. So let's just extrude up by 25. Okay, so that's the rough region we've got components in. Now we want to model the location of the power stuff, the micro SD. And once we've got that, I think we're good, right? It's basically all we need for this project. So basically that's going to be like this region over here. And I think again, the way I'll approach this is I'll just cut out regions of the case. I'm wondering if it should just be one big cut or if I should do two. one cut to expose all the power stuff and the reset button, and another one to expose the card, or just one all the way across? It might not look the fanciest, but I'm kind of thinking I want to just expose all the way across. That's simple and easy, right? And that's what we need right now. So just guesstimate how far we want to go. I'd say 20 millimeters. 20 millimeters should do the trick. So okay. So I'm gonna want to do a rectangle that's let's do a cube. Okay, now so in the X direction we want 20 millimeters. The Y direction we want HU depth, and then the vertical, the height, we're gonna want the 25, but a little more so it cuts it out, so 26. And then to position that, well, first of all, let's see. That didn't cut it out. That looks good though. Just translate it up. Okay, so yeah, that raised it up, but now we need to bring it down by half the depth. It's looking like it needs to be a little bit taller still. Or we didn't translate it far enough. Here, let me turn off the transparency for now. Oh no, that's fine. Okay, yeah, there we're cutting out a nice section. Now, in the X direction, yeah, that looks good. So there's a nice rendering. Now let's make this stuff transparent again. So yeah, I think that looks pretty good. And with that, I think that's everything I want to model of the HiFive Unleashed for this. So that's going to be our model of the HiFive Unleashed. And we're going to create a module, call it HU. Just make this formatting a little bit nicer. So there's our HiFive Unleashed model. There's our expansion board model. Now, when we slot them together, so the expansion board let me see here. So we're looking at it from, so yeah, it'll just be the HiFive Unleashed is going to stick off from this region here. Let me put both in the model. I'll just translate the HiFive Unleashed over a ways so that we can see it clearly. So, I don't know. So first of all, we're going to need to rotate the HiFive Unleashed by 90 degrees counterclockwise. So let's see, rotating. How do we do a rotate? Rotate XYZ, angle XYZ. I feel like that's kind of what we want, right? The one that takes an angle. Like, I'd like to just say rotate 90 degrees. Okay. So I want to rotate on the z-axis by 90 degrees. Does that going to do counterclockwise, or how does this work? So I say a equals 0, 0, 90. Is that going to do what I want? Yeah, that does exactly what I wanted. Cool. So see, now the boards are lined up with each other, but basically we need to raise the HiFive Unleashed up and then slide it over here. So first of all, let's just kind of eyeball it a little bit, and then we'll go in and do the actual thing, but you know, let's just have a little fun first. So So yeah, it's gonna kind of sit like this, very roughly speaking. That's not, you know, accurately measured or anything. I was just playing around, but this is kind of what we're doing here. But yeah, I would say we've made some pretty good progress here. Let's go ahead and model the actual FMC connector on the expansion board. So let's take out this roughly made region here and then put in an FMC connector. And then we'll you know, properly figure out where it, you know, sits. So for now, I'm going to turn that part off. And we're going to go back to working on this module. We're going to cut out this region here. Just cut out the whole region, I think. So to do that, we're going to add into this difference here another cube. So the height is also going to be the 26.6, I believe. Here, let me just okay, yeah, that's just wanted to make sure that's what I'm looking at here. Right, so we need to give it some dimensions here. So the depth is just going to be like the full depth, right? And then let's see here. So this one was minus 58. With a cube of 33. So 58 minus 33 should be around how big we want, right? So let's try 22. Okay, so there it is. Not in the right spot. I'm a little bit confused as to why, though. Because it looks like it's higher up. Or is it not higher up, it's further out? I think that's an illusion. It's further out this way, not higher up. Let's look at it from a different angle. Yeah, okay. I think this should actually be 0. Okay, that's getting closer to what we want. So it's still too high. Why is that? The cube is centered around the origin, right? By default? No, it's not. Oh. All right, because I specifically did this one not centered. For some reason I thought that was easier on that one. This one I want it centered. But that means these calculations don't really match up. Okay, well, let's work with that. Or I guess we could just do it the same way we did the other one. That'll probably be easier, honestly. So, if we're gonna do it that way, we're looking at this corner here, basically. That's where the where we're starting from. So if we want to move that down to here, it's going to be like that, right? Yeah. Now let me temporarily turn off the transparency so we can see more clearly what we're doing. It's pretty glitchy, the rendering, but I think we've cut through the top but not the sides, basically. Okay, now these other two sides. So yeah, something like that. Although I meant this to go all the way up to here. So what did I do wrong there? Seems around 25 is where it's at. Let's see if we can confirm that. So it starts at 33. 33 width. And the location it starts at is exp width divided by 2 minus 58. So shouldn't it be like that? It appears so. So yeah, that will be 25 when you do the math, right? Okay, so that seems good. We just need to make it a little longer in the X direction now. Until it cuts it out. A little bit more, it seems. And it does leave a little bit there. So let's go just a teeny bit over so that we get rid of that wall. Okay, now let's add in the FMC connector to that. So where is that going to go? Let's start taking some measurements. Okay, I'm going to start noting down some measurements. That one was 58 millimeter. Okay, now this end of it. Let's call it 1.5 or 15 millimeters, I mean. Now let me just take a moment and compare here. So for our expansion board, 5715, 8 high. That makes sense. So we're seeing about like 0.5 millimeter of thickness, you know. Because this one needs to slot into the other one. Or I mean like the other one, the one we did before needs to slot into this one, so it should be a bit bigger. I feel like I just want to add 1 millimeter around each side. Yeah, I think I just want to like widen it by 1 millimeter all the way around. Although, yeah, I feel like that's what I want to do. So if that one was 57, let's make it 59 by 17. Just gonna make it a little bigger. And then That one was 8 high. Let's see how high this one is. Just eyeballing it here with a ruler, but I'd want to say it's like 7. Which sounds fair to me. Let's just call it 7. So I'm being a little bit loose with the measurements, but when we actually have the boards connected, that's what we're going to do, is like we're going to connect the boards and then, you know, measure how high off the ground, which we already did that measurements at one point, but we might redo the measurement again just to make sure. But yeah, we'll figure out, you know, like the distance there, and then we'll compare with kind of the measurements we're making now. So we'll slot, you know, we'll do these measurements and then we'll slot the board in the model, and then we'll compare what we actually measure when we connect the boards to what it should be in the model, right? And then we'll adjust it accordingly to account for how it sits when it's socketed in reality, you know, because that may vary a bit compared to, you know, our little model here. And we want to, you know, stay in touch with reality. We're trying to model an actual object here, so you know, when you connect the parts together, you want to make sure, you know, your model is reflecting how they actually sit next to each other, or relative to each other, I mean. Okay, so this is basically the cube that we've got going on here. So yeah, now we just need to figure out how to translate it. And I suppose I'll put it over here. Okay, so we're going to need to translate this. Okay, so where does it go? So first of all, it's going to need to sit on top of the board. So we're going to want to raise it up that high. So let's start with that. EXP standoffs plus EXP height So I'm not sure if that's the right height yet, but we'll figure that out as we go. Also, do I have that pointing the right way? I think I don't. I think I need to flip my... Oh wait, no, that's right. Yeah, that's right. Okay. Now, so it's going to need to go along the x-axis. Okay, now let's take a moment and look at this here. Okay, yeah, that looks good. That's what we want. Just need to move it into the right place, but that's the right height. Okay, now we just need the right location. So let's take a look here. So I think we're looking at 1 meter in, like a 1 meter lip again. So like that. And then the other direction. Let's call it 5. So yeah, like that, basically. And then I'm going to cut out a smaller cube inside of it. Which represents the region that the FMC connector on the HiFive Unleashed slots into. You know, that's like the empty space where it's going to slot into, basically. So, okay, so this is going to be 15. $57. And then let's just guess and say it goes, you know, it's going to go 6 deep. You know, I don't know exactly how far. That's the bit where we're going to have to compare it with the, you know, the real world measurement and see how close our model is getting to reality. But, you know, we're just going to say something like this, right? And then we're translating it. It's going to be a pretty similar transformation. So if that was minus 18, this one would be like what, minus 16? And then this one would be like, or wait, other direction maybe? Because this one would be, or no. I don't know, we'll see when we get there. This one's gonna be like -7, I think. Okay, so yeah, I think we went the wrong direction here. Or no, that's not what I wanted. Okay, and then okay, well, I just kind of guesstimated that, but I think I got what I wanted. Okay, now. Now let's actually, you know, put this thing in. So first of all, let me line it up. So I'm gonna raise it a bit. Bit more. Okay, now let me move it over. Wrong way. It's looking pretty close. Start lowering it. Or wait, that's not what I wanted. Okay, now let me check the other side. Okay, yeah, that's looking good. Now, I basically want it to go down by 6, right? So something like that, basically. So that's kind of what I imagined in my head. And now the question is, let's, actually match it up to reality and see how good of a job we did, right? By actually measuring the thing. And I think that looks pretty good. I mean, I'm pretty happy with what we've done there. Now, let's, why is this solid? That should be a transparency again. Wrong thing? This one. There we go. So this is our rough model that we've made so far. It's really starting to come together. I'm pretty happy with what we've accomplished here. The next thing to do is compare how it actually sits when, we've actually physically done what we've just done here on the model, and then do any corrections that we find necessary. And then after that, we just need to do the same procedure for the graphics card and the USB card. And after all that, we'll start, putting a case around it, which should be a lot of fun. How much time do I have? Oh, not too much. Well, let's see. Now let's actually compare how we did here. So okay, here it's actually connected. Okay. Now, what is the height of this board is the question. What is the height of the expansion board? I think the way I want to measure this is using the standoff. So I'm measuring around 30 millimeters from the bottom of the standoff to the top of the HiFive Unleashed board. So the HiFive Unleashed board, we said we're calling that height to be 1.6. So if we say, like, 30 minus 1.6, that gives you 28.4. Okay. And then, so we're saying that distance is like 28.4. So the bottom of the standoff is 0 on our our XY plane. Or, 0 on the Z-axis. And basically we're saying that the HiFive Unleashed board should be translated up by about 28.4 for where we have it in the Z-axis. But we also need to take into account how high it is in its model, right? So in its model, the board would be this right here. So it is 15 millimeters up from the standoffs. Minus 15 gives us 13.4. and I translated it up 14. So we're pretty close, right? We're in the right ballpark. If I've done my math correctly here, I believe we are basically correct in terms of how high the board should be sitting. Maybe we've got it a little higher up than it is in the actual thing. So what were the measurements I had made before? Okay, well this 25, I was saying if we replace the standoffs, and I said rather than doing that, let's raise the case to meet those standoffs, and we'd want to raise it by 9.6-ish. Did we not, I mean, we must have measured the height, right? What do these scribbles mean? Well, this was the standoffs. So if I'm saying 25, yeah, I mean, I guess what I'm saying here is that it should be raised 9.61. So like 9 to 10 millimeters is what I was thinking, but the measurement I took now and my model are suggesting it should be more like 13 or 14. So I feel kind of inclined to trust my more recent measurements. I don't know. Or wait, no. Because this is saying if you raise this 9.61, that's, you know, then you also have the additional 15 millimeter of standoff. These standoffs are not 15. Those are the expansion board standoffs, with which are 18, right? So that explains why we said we'd want a 25 millimeter standoff. So really what we're saying here by the 25 millimeter standoff is we're saying we expect the board to be 25 millimeters up from the bottom, like the surface here, right? So I was expecting to need to raise it 25 millimeters, and my recent measurements are saying you want to raise it more like 13 or 14 millimeters, not 25. No, that can't be right. I have got myself all confused. So we're raising the model of the HiFive Unleashed up by 14. Right, but then we also add in the height of the standoffs, which is 15. So that gets us more like 29. Yeah, that's saying it's, my model is saying it's more like 29 millimeters, 29 to 30 millimeters to the, from the bottom here to the bottom of the board. That distance should be like 29-ish. Whereas before I was thinking 25-ish. But you see one of my first measurements here was 28.2. So maybe my first measurement was better, and then when I tried to correct my measurements, I was actually getting further off. Anyway, I think we're going to go with the most recent measurements, and I need to end the episode here. So thank you everybody who watches. You can catch me live in the future when I stream again. It'll be at twitch.risky.tv, and you can always catch the episodes on the YouTube archive at risky.tv. And you can follow me at HMN_risky on Twitter to get updates about the series. I don't have any new shoutouts to do today, but if you want to support this series, you can do so at patreon.risky.tv. I will see you in the next episode, and stay risky, everyone.